technical seminar on refrigeration and air conditioning. Presented by Manmatha Kumar Giri. EE 200,113,363. Under the guidance of Mr. Debashish Channal. Introduction. The electrical energy is utilized by converting it into one form or other for getting suitable output from it. The utilization electrical energy for the refrigeration and air conditioning is fast replacing the old methods. What is refrigeration and air conditioning? The process of reducing the temperature of a body from the general level of temperature of surroundings is called refrigeration. Air conditioning means control of temperature, humidity, purity and movement of air. The working conditions and comfort for human beings is improved by air conditioning. The temperature is brought down during summer and increased during winter without causing any discount. Refrigerator. This is the machine by which the temperature of substances is lowered by storing them in this machine. Principle. A refrigerator works on the principle of cooling caused by evaporation. When we dip our finger in petrol or spirit, and the finger is taken out, cooling is felt. This is because when petrol or spirit evaporates, it draws heat from the finger, thus cooling it. Refrigerant. The refrigerant is generally a gas which circulated through different stages to extract the heat from the substances. The various refrigerants used are carbon dioxide CO2, sulfur dioxide SO2, ammonia NH3, freon F12 and methyl chloride etc. Vapor compression cycle. The main purpose of vapor compression cycle is to remove heat from the refrigerant by putting it into a stage for reuse. The various stages are 1. Compression, 2. Condension, 3. Expansion, 4. Evaporation. Application. The vapor compression refrigeration cycle is employed for the following purposes: domestic refrigerator, water cooler, air conditioner, ice plant, cold storage etc. Domestic refrigerator. The actual layout of domestic refrigerator is shown in figure below. Electrical circuit of refrigerator. The main parts of the electrical circuit are shown in figure below. The various parts are: 1. Motor compressor unit, 2. Starting relay, 3. Thermostat, 4. Overload protector, 5. Cabinet light, 6. Dryer assembly, motor compressor unit. The motor is a single-phase capacitor start motor. The actual capacity of the motor depends upon the size of the refrigerator, but generally the horsepower of motors varies from 7/32 HP to 1/8 HP. Mostly the motor and compressor are in one unit and is known as sealed unit. Starting relay. The motor is operated by this relay, which is also called motor protective relay. It essentially consists of a plunger on which a coil is wound. The figure below shows the arrangement. Thermostat. A thermostatic switch is used on all the household refrigerators by which the temperature is controlled, and it is called thermostat. The construction of a thermostat used in a refrigerator is shown in figure below. Overload protector. This is a thermal device which opens the circuit of the motor when overloaded and is called overload protector. The figure below shows the enlarged view of overload protector. Cabinet light. This circuit contains a lamp and a switch. The switch is called door switch and so installed that when the door is closed, the bulb remains off. When the door is opened, the bulb remains on. Dryer assembly. This assembly is not employed on all the domestic refrigerators. This is a high-resistance wire passing around the dryer to remove the moisture from the refrigerator. This is connected across the supply by the thermostat. Air conditioner. The room air conditioner is used to condition the air of the particular space occupied by the human beings, i.e. office, room etc. It has automatic operation to control and maintain the humidity of air. There are two parts divided by a partition with a small opening at the top as 1. Outdoor part, 2. Indoor part. Air conditioner. The complete operation of an air conditioner can be studied under these subheadings. 1. Vapor compression cycle, 2. Air circulation. 3. Electrical circuit. The figure below shows a room air conditioner. Conclusion. The electrical energy is utilized by converting it into one form or the other form for getting suitable output from it. The utilization of electrical energy for the refrigeration and air conditioning is fast replacing the old methods. Refrigeration and air conditioning has become a necessity in every sphere of human utility and industrial setups. Thank you.
Basic refrigeration, its components, and its cycle. Mingledorff's Incorporated. Basic refrigeration, its components, and its cycle. Introduction to refrigeration. Refrigeration, cooling to preserve products and provide comfort. Types of refrigeration processes. High temperature, air conditioning, comfort cooling. Medium temperature, food preservation, keeping product cool. Low temperature, food preservation, freezing of the product. What is refrigeration? Remember, heat flows from warm to cold. The process of transferring heat from a place where it is not wanted to a place where it makes little or no difference. Remember, heat flows from warm to cold. 1 ton of air conditioning equals the removal of 12,000 BTUs per hour. How do we rate air conditioning equipment? 1 ton of air conditioning equals the removal of 12,000 BTUs per hour. 4 major refrigeration system components. The evaporator, the compressor, the condenser, the metering device. The 4 major components. The evaporator, a heat exchanger to absorb heat. Evaporator coil, used to absorb heat from the conditioned space or product. Located on the low side of the sealed system between the metering device and low side of the compressor. The evaporator operates at temperatures colder than the medium passing across the coil. Absorbs heat by boiling a low temperature liquid to a low temperature vapor. Metering device feeds liquid refrigerant into the evaporator. Under standard conditions, the mixture coming into the evaporator is 75% liquid and 25% vapor. The evaporator. Superheat, the heating of the vapor above the refrigerant saturation temperature. Superheat ensures that no liquid returns to the compressor. Design evaporator superheat ranges from 8 to 12 degrees Fahrenheit. Superheat is determined by subtracting the evaporator's saturation temperature from the temperature of the outlet of the evaporator. The evaporator. The compressor pumps heat-laden vapor from the evaporator to the condenser. The compressor reduces the pressure on the low side of the system. The compressor increases the pressure on the high side of the system. The compressor. Most common types of compressors used are the reciprocating, the rotary, and the scroll. Positive displacement compressors require that the compressed gas be moved into the condenser or damage will occur. The compressor. The compressor. The condenser rejects sensible and latent heat from the system that was absorbed by the evaporator and the compressor. Located on the high side of system. The condenser. The heat is released from the refrigerant in the condenser, causing it to change state from a high temperature, high pressure vapor to a high pressure, high temperature liquid. Condensing temperature is determined by the system's head pressure. The condenser. The condenser normally subcools the liquid at the end of the condenser. Subcooling is lowering the temperature of a liquid below saturation. Standard air-cooled condensers are designed to subcool a liquid by a minimum of 10 degrees Fahrenheit below the saturation temperature. Amount of subcooling is determined by subtracting the outlet temperature of the condenser from the condenser saturation temperature. The condenser. The refrigerant metering device controls the flow of subcooled liquid refrigerant into the evaporator. Orifice metering device creates a pressure drop between the high side and low side of the sealed system. 25% of the liquid leaving the metering device turns to vapor called flash gas. The refrigerant metering device. The refrigerant metering device. Low side/high side. The refrigeration system. Compressor. Low pressure vapor. Low pressure liquid. High pressure liquid. High pressure vapor. Liquid. Refrigerant. Receiver. Evaporator. Condenser. Texas. Valve. Accumulator. Oil separator. Dryer. Solenoid. Sight. Glass.
Refrigeration. Introduction. Refrigeration is defined as the process of extracting heat from a lower temperature heat source, substance, or cooling medium and transferring it to a higher temperature heat sink. Refrigeration maintains the temperature of the heat source below that of its surroundings while transferring the extracted heat, and any required energy input, to a heat sink, atmospheric air, or surface water. A refrigeration system is a combination of components and equipment connected in a sequential order to produce the refrigeration effect. Applications of refrigeration. Preservation of perishable food products by storing them at low temperatures. Refrigerators. Freezers. Cold stores. Providing thermal comfort to human beings by means of air conditioning. Window-type air conditioners. Split-type air conditioners. Chillers. History of refrigeration. Natural refrigeration. Using ice. Transported from colder regions. Harvested in winter and stored in ice houses for summer use. Made during night by cooling of water by radiation to stratosphere. History of refrigeration. Natural refrigeration. Evaporative cooling. The process of reducing the temperature of a system by evaporation of water. Human beings perspire and dissipate their metabolic heat by evaporative cooling if the ambient temperature is more than skin temperature. Example, earthen pots. The water permeates through the pores of earthen vessel to its outer surface where it evaporates to the surrounding, absorbing its latent heat in part from the vessel, which cools the water. History of refrigeration. Artificial refrigeration. It is generally agreed that artificial refrigeration began in 1755, when the Scottish professor William Cullen made the first refrigerating machine, which could produce a small quantity of ice in the laboratory. He placed some water in thermal contact with ether under a receiver of a vacuum pump. The evaporation rate of ether increased due to the vacuum pump and water could be frozen. History of refrigeration. Artificial refrigeration. The process demonstrated by Cullen was not continuous. The vapors have to be recycled by condensation to the liquid state. The condensation process requires heat rejection to the surroundings. Therefore, the vapor has to be at a higher temperature than the surroundings. To increase the vapor's temperature, the pressure has to be increased. A compressor is required to increase the pressure,